Have you ever rubbed a balloon on your head and watched your hair stand on end? That's static electricity, and it's all thanks to something we call an electric field. Now, let's break down what that means. Now, what is an electric field? An electric field is like an invisible force field around any charged object. Think of it as a zone where other charges feel to push or pull. Strength depends on two things: how much charge the object has and how far you are from it. Electric field has two formulas. The first one is E is equal to F over Q, which tells us the field strength. E is the force divided by the test charge Q. And for the single charge, it's E is equals to KQ over R squared, where K is a constant value of 8.99 times 10 raised to 6. Q is the charge and R is the distance. Don't you worry, you don't need to memorize this. Just know it gets quicker as you move away. Examples.
Now, for our first problem, a small test charge of 2 microcoulombs experiences a force of 0.04 Newton when placed in an electric field. What is the magnitude of the electric field? Our first step is to identify the given. Our given in this problem is 0.04 for our electric force, while 2 microcoulombs for our charge, which will be converted into coulombs like this. 2 microcoulombs times 1 microcoulomb over 1.0 times 10 raised to 6 coulombs, which is equal to 2 times 10 raised to negative 6. Now, for RE, our E is the required. So, the thing that we are finding is our electric field. Now, step 2 is to identify the formula to use. The formula to use in this problem is electric field equals electric force over charge. Step number 3, substitute the given to the formula. We will just substitute the given into the formula that is shown in the step number 2. So it will become like this: electric field equals 0.04 N over 2 times 10 raised to negative 6. Now, we'll just proceed to solving the problem. In order to solve the problem, we will just use step 3. It will become 0.04 N divided by 2 times 10 raised to negative 6. So it will become 20,000. So 20,000 newtons per coulomb. So our final answer will be our electric field is 20,000 newtons per coulomb.
For the second problem, a point charge of 5 microcoulomb is placed in a vacuum. What is the electric field at a distance of 0.2 meters from the charge? First, let's identify the givens. K is equals to 8.99 times 10 raised to 9 Newton multiplied by meter squared. Q is 5 microcoulomb and the R is 0.2 meters. Then, we will gonna use the formula. Electric charge equals KQ over R squared. But first, we will convert the microcoulomb to coulomb. To convert, we will first put the 5 microcoulomb times 1 because 1.0 times 10 raised to the power of 6 is microcoulomb. We will cancel the units. Then let's solve. The answer is 0.000005. After converting, we substitute the formula. Here is the substitute formula because this is a constant value. The Q, which is the one that we convert, is 0.200005. And the R, which represents the distance, it is 0.2 meters squared. And this is the numerator. This is the denominator. Then, let us cancel the units. After cancelling the units, let's multiply the given numerator. 8.99 times 9 raised to 9 multiplied by 1.000 equals 44950. So that is equals to 44950. Let's bring down the denominator. 0.2 times 3. We get 44950. Then, after that, we divide it by the distance. 0.2 times 3. The final answer is 1128750. This is the final answer, but keep in mind that if you get a scientific notation answer format, it is still right. It depends on the counting of the number.
Now, for the third and last problem, we will have a uniform electric field of 5,000 newtons per coulomb is directed to the right. If a charge of 2.67 times 10 raised to negative 6 coulomb is placed in this field, what is the force acting on it? Again, our first step is to identify the given. The given here is 5,000 newtons per coulomb for our electric field. And 2.67 times 10 raised to negative 6 coulomb for our charge. So, the difference is our missing here or required is our electric force. Now, for the second step, we need to identify the formula to use. We will still use the formula E equals F over Q, but we will need to crisscross the formula in order to get the right formula when finding our electrical force. So it will become F is equal to electric field times charge. Now, we just need to substitute the given to the formula. Electric force equals to electric field, which is 5,000 newtons per coulomb, times 2.67 times 10 raised to negative 6 coulomb for our charge. Now, we will just proceed to solve the equation. Electric force is equal to 5,000 newtons per coulomb times 2.67 times 10 raised to negative 6 coulomb, which our answer will be 0.01335, or when we round it off, it will become 0.01. Now for the final step, we already have our final answer. Now, our electric force is 0.01 newtons. And remember, we will also need to cancel out both C's because they are present in both values. So our final answer will become 0.01 and the remaining n. So it will become 0.01 Newton.
There you have it. Electric fields are everywhere. So next time your hair stands up, remember it's not a magic, it's science. Electric fields are the invisible forces making it all happen. Thanks for learning with us, and go shocks your friends with this knowledge. Bye!